Hey students, this is lesson 5.3. In this lesson we're going to learn how to identify properties of perpendicular bisectors and angle bisectors, mostly in triangles. Go ahead and do the review, I'll check back with you. All right, so here's the important idea for perpendicular bisector theorem. The perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. So if you look at this picture, when you draw the perpendicular bisectors of the three sides of a triangle, that point will be equidistant from each of the vertices. All right, so we're going to use that idea. And notice that if it is equidistant, then you could draw a circle around that triangle. That triangle will be inscribed in the circle. So the circle is circumscribed about the triangle. And so that point is the center of the circle with all 3 points of the triangle on it. And so we call that the circumcenter of the triangle. And the circumcenter can be either inside the triangle. That would happen if you have an acute triangle. On the triangle, that would happen if you had a right triangle, and outside the triangle, which would happen if you had an obtuse triangle. So, finding the circumcenter of a triangle. Let's look at this problem here. We have vertices at 0, 4, 0, 0, and 8, 0. We wouldn't need a graph to do this, but I'm going to put up a graph so you can kind of see a little bit better what's going on here. All right, so I drew my triangle here, ABC, and what we need to do is find the point that's equidistant from the three vertices, which is the circumcenter, and the point is the intersection of the perpendicular bisectors of the three sides. So if I draw the bisectors of three sides, the perpendicular bisector, this side, the perpendicular bisector, and to be at the perpendicular bisector, we need to be on the midpoint of that side, and then we need perpendicular. And since side BC is a horizontal line, a vertical line would do that. So there's that one. And then I can also find the perpendicular bisector of side AB by just drawing a horizontal line through the midpoint of side AB, which is at 2, right there. And then the third side has a perpendicular bisector also, but as you probably noticed, this point right here will be the midpoint of side AC because I found the midpoint of AB and the midpoint of BC. So we don't need to find anything more. So I'm just going to label that point for 2. And if I measured that distance, and that distance, they would all be equal. And think about Pythagorean theorem, all those little triangles have legs. The two legs are the same length, so those distances would be the same. Go ahead and try problem 1 on your own. All right, so we're going to do a problem here. A civil engineer wants to install a cell phone tower that is equidistant from the mall, the airport, and the subway. How should the civil engineer determine where to build the tower? And if it's equidistant from each of those points, we could think of a triangle connecting those points. I'm just going to draw a line through each of those points. So what I need to do is locate the circumcenter of that triangle now, and we can do that by drawing perpendicular bisectors, or finding the perpendicular bisectors. If it's on a paper like this, we can use a compass to do that. And all I would have to do is find the perpendicular bisector of each of these sides. And if you remember how to do that, I'm actually just going to draw a circle around these and you'll see where each of these intersect. By drawing the whole circle in, you'll see that it saves you a little bit of time. them all. And then you can just draw a line from, for the perpendicular bisectors, this line right will go right there between those 2 points. This line will have a line between these 2 points. That's another perpendicular bisector. And there's one more perpendicular bisector right between those 2 lines. And where they all 3 intersect, right in the middle there, that is the point that will be equidistant from the mall, the airport, and the subway. All right, you try that. If I now get rid of these perpendicular lines, it looks a little cleaner. And there's the point that's equidistant. All right, here's your answers to that problem. All right, here's theorem 5.7, concurrency of angle bisectors theorem. The bisectors of an angle, so now we're bisecting the angles, not the sides, are concurrent at a point equidistant from the sides of the triangle. So once we find this spot, it'll be equidistant there. So Px is equal to Py is equal to Pz. And since this center is equidistant from the sides, we'll be able to draw a circle inside. And so this is called the incenter of the circle. And the point of concurrency of the angle bisectors of a triangle is the incenter. So it kind of makes sense because the circle will be drawn inside the circle. The point of concurrency of the angle bisectors of a triangle is always inside the triangle in this case. And the circle is inscribed, not circumscribed, like the circumcenter. All right, so let's use that idea here. And so if GB equals 8x minus 7 and GD equals 5x plus 8, let's find what GF is. What is the length of GF? So we know that from the theorem, the angle bisector theorem, that GB is equal to GD. And so 8x minus 7 is equal to 5x plus 8 by substituting. And so 3x is equal to 15, and we get that by using some properties of equality. And so x is equal to 5. And then we know that GF is equal to GD, which is 5x plus 8. So we're just going to substitute 5 for x, and we get that the length of GF is 33. All right, I'll fill in the reasons for you. All right, you try that. All right, here's your answers to that. We're ready to do the lesson check. Go ahead and do that, and we'll talk about it next time we meet in class.